Hi everyone. So next we want to discuss how to decide the degree D. So we discussed two methods. The one is AIC and the other is ANOVA, so test. So first ANOVA, the AIC. So we want to have the model with the maximum prediction power. Remember that we defined LM2. This is the polynomial regression with degree 2. So we want to define higher degree regression model. So LM3 to LM7. So nil on polynomial with degree 3. And the same way 4, 5, and 6 and 7. So you can use a for loop to do this job also. Maybe you can make a list and you can include the LM2 to LM7 in the list. But here, just we want to make it intuitive, so we define LM3 to LM7 here. So at first, we want to see graphs. So original graph is here, and we want to overlay regression curve. So LM1 is original, linear regression. So this is a straight line. And we want to overlay second degree polynomial. So here, so it seems slightly better. So red one is the degree 2, slightly better than degree 1. And go beyond that, degree 3. Color 3 is green. So the 3 is here. Actually, 2 and 3 aren't really different. Basically because on both sides, basically observations goes up here and goes up here. So that's why 2 and 3 doesn't make much difference. How about 4? So this is slightly different. So we have higher values here around 1880, but also the higher in around 1950 to 55, and lower in between. And possibly this fit is better than 2. And you can see as a polynomial 5, 6, and the 7 is color 7 is yellow. So maybe we can go back color 1 and we change the line type to dashed line. So you can see these graphs. Actually, 2 and 3 are similar, and 5, maybe 4, 5, 6 are similar. The 7 is a little too bumpy. So probably there's somewhere between 2 to 7 are appropriate. So now that we want to compare the AIC. Again, the AIC that you can use for loop to get all AIC at once, but here we do it manually, AIC of LM1 to LM7. So 1, 2, 3, 4, 5, 6, and 7. Then we want to make a plot. So degree of polynomial on x-axis and AIC value on y-axis. X-axis is again the degree of polynomial. Then you can get this plot. So from here, 4 and 7 have almost the same AIC, but the 4 is much simpler model, so probably most people want to choose 4. If we go beyond 7, possibly it can have lower AIC, but it sounds reasonable to choose d is equal to 4 for this problem. Okay, so another way to decide degree is testing. So for each additional the term of the polynomial, we want to see if that makes significant change. So that test can be done by ANOVA. You can just put all linear model, nested linear model in order. Then you can get this. So this output says that the polynomial with degree 2 is significantly better than polynomial of degree 1 because the test p-value is very small. It's much smaller than even 0.001. But you can see degree 3 polynomial is not significantly better than 2 because p-value is 0.74, so it's much larger than 0.05, so we cannot say this is significantly better. But one difficult point is if we go d is equal to 4, that is actually much better than 3. And 5 is not better than 4, 6 is not better than 5, and 7 is better than 6. So it's hard to decide, but we can get some information on how to decide the polynomial. Probably we will choose 4 or 7. Okay, so this is how to compare the the polynomial regression and how to decide the D. Okay, see you then.